So part two of this video is going to pick up where part one left off. We finished up talking about how elements are all around us, from the prepackaged stuff that we buy to your cell phones. And I was quite amazed a couple years ago when Twinkies went out of business and they showed us the 39 ingredients that go into a Twinkie bar that we enjoy on a day-to-day basis. So I want to pick up where this video left off in video 1 and video 2 and start off with the video about the secret ingredients in the Twinkie and kind of just amaze you at what's in the stuff that we eat.
Hostess turns out 500 million Twinkies every year. 500 million! Each one is made from flour, sugar, corn syrup, things you might expect. And then there are a whole lot of things you might never expect, unless you normally eat glue and rocket fuel. For instance, there is corn dextrin.
Is a great glue. It's the glue you find on the back of envelopes that you lick. It stays dry. When it's dry, it's not so sticky. When it's wet, it sticks right together.
How could you have one and not eat one?
And there is cellulose gum. In the Twinkie, it gives the cream the smooth feel.
It's in a lot of low-fat salad dressings, ice creams, and it's used in rocket fuel to give a slightly gelatinous feel to the rocket fuel. I just love that.
Rocket fuel? It's a strange kind of fun.
And fun is having a Hostess Twinkie. Light and
When Ettlinger laid out a bunch of the ingredients in the Twinkie, it didn't look much like a magical flying Twinkie romp. Nor did it look much
Look
like
at that.
a bakery.
It looks like a chemistry set. It is. It's like a chemistry set. And I have to tell you, I really enjoyed coming through the airport security with these big rocks.
That's right, rocks. At least 5 rocks go into making a Twinkie. There is trona in the baking soda, limestone in the baking powder, and of course, salt.
Is there anything wrong with the fact that Twinkies have 39 ingredients and are made from rocks and use petroleum? No, because if there were, there'd be something wrong with all our processed foods. Now, some people don't like that, in which case they can eat more whole foods, fruits, vegetables, and what have you.
I have all real, what I call
Okay, so stopping there, I mean, I don't know if your mouth dropped when you kind of saw some of the stuff that you eat, but going back to the periodic table of elements, this is everything that is non-living at the microscopic level. I mean, again, it's the metals, non-metals, metalloids, the gases. I kind of like this periodic table because, again, it kind of gives you an outline of the atomic number, and it kind of shows you that 6 represents the number of protons in a carbon atom. Down here is the atomic weight, and it actually tells you pretty much the weight of the nucleus of that atom. So in relative terms, a carbon atom will weigh 12.00 or 0.011 or 12 and 11 thousandths AMUs, and you'll hear me talk about that more in class. AMUs represents atomic mass units. The other thing I like about this is it tells you what this element is like at room temperature. So the boxes mean the solids, the water droplets mean the liquids, and then the clouds mean the gases. So looking at this at room temperature, pretty much most of the stuff is in a solid form. But again, here's your halogen group. You've got your gases, you've got your liquid, and then you've got your solids. But down here, when we started talking about your isotopes, you have this little radioactive symbol starting. You kind of see where as we move down the periodic table of elements, more stuff becomes radioactive. So it's kind of scary, some of the stuff that we use. There's stuff that goes in your blood to, track where your blood flows, and you can look at x-rays and lots of other tools and measurement in medical science to look at more stuff at a smaller level. So I kind of want to start just kind of reviewing some stuff with you guys, and I just kind of want to give you guys a quick quiz here, and you guys can kind of test your knowledge to see, do I truly understand the periodic table of elements? Do you remember the alkali metals, the alkali earth metals, the non-metals? Do you understand what let me back up here. Do you guys understand kind of what the 6 means, the C means, the 12.01? So the first question I want to ask you is this staircase effect that I kind of talked about in that first video, and we had like the green boxes outlined. What does this kind of represent on the periodic table of elements? Okay. Next question. Okay, where is the halogen group? Is it, in group 7, group 8, group 9, or group 10? Okay. Moving on. Okay. Which side of the periodic table of elements has pretty much mostly metals? Okay, next question then is which side of the periodic table is basically made up of the non-metals? Okay. Next question is which color, green, blue, red, or yellow, represents the alkali metals? Okay. And the next question, we talked about carbon having the number 6. What does that 6 actually mean? The next question, where can I find all the noble gases on the periodic table of elements? Would it be the green? Would it be the purple? Would it be the blue? Or would it be the brown? Hmm. And the final question, what do we call these rows on the periodic table going across that pretty much they repeat similar properties as they go across? What do we call that? Hmm. And basically, as we finish up, and you guys can kind of see how you did on this quiz, on this video, if you have any questions, you can always write them down, bring them to class. But hopefully this video that I put on the website for you guys would be a great review for you guys to watch and kind of, again, get a better understanding of how the periodic table is set up.